Hello, my name is TTJ Kepsi Richard. Welcome. Today our discussion will be on trigonometry. Before the video ends, I will introduce you to the basic understanding of trigonometry. Then we will try to solve some problem involving trigonometry. Please, this will be a very interesting engagement, so be my guest. So, trigonometry takes its very foundation from Pythagoras Theory. And what does Pythagoras Theory say? It says that in any right angle triangle, the longest side, that's the hypotenuse, which is the longest side square, is equal to the square of the other side, that's the opposite square, and plus the adjacent square. The opposite is always the side against the angle in contention, and the adjacent is the other side. So, Pythagoras theory play a very basic foundation in understanding trigonometry. Now, how does the trigonometry comes in? Trigonometry comes in if we try to find the angle, one of these angles, trying to find one of these angles using the side of the triangles. That's the angle here, which is theta. We try to find it using the sides of the triangle. That's where the trigonometry comes in. How do we find the angle? We find the angle using basic trigonometric identities. And the three basic trigonometric identities are sine, which is shortened as sine, but we pronounce it sine, cosine, shortened as cos, then tangential, shortened as tan. Now, how do we use these trigonometric identities to find the angle in the right angle triangle involved? We use a very basic mnemonic scheme known as SOHCAHTOA. Now, what does the SOHCAHTOA mean? The mnemonic scheme SOHCAHTOA. What does it mean? It simply means that when we want to find this angle here, sine of this angle will be equal to the opposite over the hypotenuse. The opposite here is B over the hypotenuse, which is A. Now, cos of the angle, cos theta, is equal to the adjacent over the hypotenuse. The adjacent is C over the hypotenuse, which is what? A. Then, tan of the angle, or the tangential of the angle, is equal to the opposite over the adjacent. The opposite, which is B, over the adjacent, which is C. So, this is where the trigonometry comes in. When we try to find the angle in contention using the sides of the triangles. So, we say that the sine theta will be the opposite over adjacent, cos theta is adjacent over the sine theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, and tan theta is opposite over the adjacent. Now, I want to divide sine theta by cos theta and see a certain relationship will pop up. So our sine theta is B over A, then divided by cos theta, which is C over A. So this can be simplified as B over A times A over C. So this A will divide that A, will have B over C. Look at it. Our B over C is tan theta. Then we can say that sine theta divided by cos theta is equal to tan theta. A very basic identity or relationship between the trig identities. Very, very important. So sine theta over cos theta is always equal to tan theta. Now let's see how we measure trig angles. Then we'll try to solve some problems using the trig identities. So what I want you to understand at the first place is that trigonometric angles are measured in anti-clockwise direction. unlike bearing that is measured in clockwise direction. So in trigonometry, we measure angles in this way. And also, we have a very simple mnemonic scheme to measure or find the quadrant in which a trig identity is located. And that mnemonic scheme is all silicon cat. All silicon cat. What does it mean? It means that all the trig identities, all the three basic trig identities, that are sine, cos, and tan, are all positive in the first quadrant, where the angle is maybe greater than 0 bar, less or equal to 90 degrees. So, in the first quadrant, all the trig identities are positive. Now in the second quadrant, where the angle is greater than 90 degrees, but less or equal to 180 degrees, only sine is positive in that quadrant. So the C stands for sine, only sine positive. Then in the third quadrant, only tan is positive in that quadrant, when the angle is greater than 180, but less or equal to 270. Then in the last quadrant, which is the fourth quadrant, only cos is positive in that quadrant. That's when the angle is greater than 270, but less or equal to 360. So we say the first quadrant, all the three basic trig identities are positive. But in the second quadrant, only sine is positive. That's tan and cos. Only sine is positive, tan and cos are negative. In the third quadrant, only tan is positive, sine and cos are negative. Then in the fourth quadrant, or the last quadrant, only cos is positive, sine and tan are negative. I hope you get that. So now, after we know how to measure trig identities, let's see how we can solve some problems on trigonometry. So, since we have got all the necessary tools that will enable us to solve problems on trigonometry, let's take our first problem. So that given that sine theta is equal to 3 over 5, find cos theta and tan theta. If theta is less or equal to 0, theta is greater or equal to 0, but less or equal to 90 degrees. So now, how do we do that? Remember, our mnemonic scheme, say, so, ka, twa. So when we have our right angle triangle, and this is theta, then we can say so is opposite over hypotenuse. Then if we have sine theta, then the opposite is the 3, and the hypotenuse is 5. Then we need to find our adjacent. Let's say our adjacent should be, let's say, A. So from Pythagoras Theory, we say 5 squared, the hypotenuse square, is equal to the square of the sum of the other sides. So 5 squared is equal to 3 squared plus A squared. 5 squared is 25, 3 squared is 9 plus our A squared. So A squared can be equal to 25 minus 9. So our A squared will be equal to 25 minus 9 is 16. So A will be equal to the square root of 16, and A will be equal to plus or minus 4. That's the square root of every number is plus or minus that number. However, they say theta is greater or equal to 0, but less or equal to 90. This implies that theta is found in the first quadrant. And in the first quadrant, all the trig identities are positive. That's all are positive. So the negative aspect may not be necessary in this case. So we can say our adjacent is 4, since all is positive. Then we can find cos theta. So our cos theta will be equal to, remember, cos theta is adjacent over hypotenuse. What's our adjacent is 4, which we found. What's our hypotenuse is 5. So we can say cos theta is 4 out of 5. Then tan theta will be equal to. So remember tan theta from our mnemonic scheme. We said tan theta is opposite over the adjacent. What's our opposite? Is 3. What's our adjacent? 4. So tan theta will be 3 out of 4. I hope you get that. Very simple. So when it is given to you, just try to use Pythagoras to find the other side. Then you find you try to solve the problem or what the question is asking for. We solve more questions on this. So let's solve our second question. It says given that tan y is equal to negative 1 over 4 and that y is greater than 90 but less than 180, we should find cos y and sin y. So this relation or this interval given indicate that y is found in the second quadrant. And what happened in the second quadrant? In the second quadrant, only sine is positive. That buttress to our point that the tan y given is negative. So cos and tan are negative in that very quadrant. Remember, only sine is positive. So now let's go. We need to use the Pythagoras theory to find all the 3 possible sides. So this will be our y. So from our SOHCAHTOA, our mnemonic scheme, SOHCAHTOA, our tan is opposite over adjacent. So 1 over 4, the 1 is the opposite, and the adjacent is 4. So we can say the side against the angle is the opposite, and this will be 4. So the other side, which is the hypotenuse, we can give any variable to it. So let's say a. So from Pythagoras theory, a square will be equal to 1 square plus 4 square. A square will be equal to 1. 1 square is 1, 4 square is 16. So our a square will be equal to 17. A will be equal to the square root of 17. And the square root of 17 will be plus or minus root 17. Remember, the square root of every number is plus or minus that number. Now, this implies that when we are finding sine, we'll take the positive aspect. But when we are finding any of the identities, we'll take negative. Remember that. Very, very necessary. So we can say that our cos y, remember cos is also negative in that quadrant. So cos y is adjacent over hypotenuse. What's our adjacent? 4. And what's our hypotenuse? Is root 17. That's plus or minus root 17. However, since cos is negative in the second quadrant, we'll take the negative aspect. So 4 over root 17. So we can say cos y will be equal to negative 4 over root 17. Now we can find sin y. Remember, sine will be positive in that quadrant. So sin y, which is opposite over hypotenuse, our opposite is 1. And our hypotenuse is root 17. So positive root 17. So we can say cos y is negative 4 over root 17. And sin y is 1 over root 17. I hope you get that. So let's look at our third question. It said, if cos x is equal to p, find sin x and tan x in terms of p. This is another interesting one. Since the interval is not given, you presume that x is found in the first quadrant. Very, very important. That's all is positive. So let's draw our right angle triangle again, where our x is here, which is the angle. Remember our mnemonic scheme, SOHCAHTOA, where sine is opposite over hypotenuse and cos is adjacent over hypotenuse. So the cos is given to be p. Remember, every whole number is over 1. So this cos x being equal to being p, the p is over 1. Very, very important. So we can say that our adjacent is p and the hypotenuse is 1. So the adjacent here p, hypotenuse 1. Then we can find our opposites. From Pythagoras Theory, the hypotenuse, which is 1 square, will be equal to p square plus a square. So we find a in terms of p. So 1 square is 1 equal to p square plus a square. Then our a square will be equal to 1 minus p square. So a will be equal to the square root of 1 minus p square. Remember, plus or minus the square root of every number. Now we can find sin x and tan x. So our sin x, remember, is opposite over hypotenuse. What's our opposite? Our opposite is, please, since it's found in the first quadrant, we only use the positive aspect. That's the square root of 1 minus p squared. So our opposite is the square root of 1 minus p squared. So sin x will be the square root of 1 minus p squared over the hypotenuse, which is 1. So this sin x will just be the square root of 1 minus p squared. Now we can find tan x. Remember, tan x, tan, opposite over adjacent. What's our opposite? 1 minus, the square root of 1 minus p squared. And our adjacent is p. Then we can say tan x is the square root of 1 minus p squared all over p. I hope you get that. So sin x will be the square root of 1 minus p squared, and tan x will be the square root of 1 minus p squared all over p. So let's see another twist of these three problems. So given that tan x is equal to 1, where x is less or greater or equal to 0 but less or equal to 90. This implies that s is found in the first quadrant, where all the three trigonometric identities are positive. We should evaluate 1 minus sine square x over cos x. So how do we do that? We need sine x and cos x. So from our Pythagoras theory, where s is the angle, remember our mnemonic scheme again, very, very important. Our SOHCAHTOO. The tan which is given is opposite over adjacent and is equal to 1. Remember, this is a whole number, so it's also over 1. That means the opposite is 1 and the adjacent is also 1. Then we need to find the hypotenuse. So we can say our a square is equal to 1 square from Pythagoras theory plus 1 square. A square will be equal to 1 square is 1. So we say 1 plus 1. A square will be equal to 2. A will be equal to plus or minus the square root of 2. But since it's found in the first quadrant where all of them are positive, the negative will not be necessary in that instance. So we can find our sine. Our sine x, remember, is opposite. So this root a will be equal to root 2. Our sine x will be opposite over hypotenuse. Our opposite is 1. Our hypotenuse is root 2. Only the positive aspect. Then our cos x will be equal to adjacent over hypotenuse. What's our adjacent? Is 1. And our hypotenuse is still root 2. So since we know our sin x and cos x, we just substitute into this expression to evaluate it. So we will evaluate this. So we just substitute our 1 minus sine square x over cos x will just be equal to 1 minus, what's our sin x? Sin x is 1 over root 2. So 1 over root 2 or square over cos x, which is 1 over root 2. What will we have? Remember, root 2 square is the same as is 2. So this place we have 1 minus 1 square is 1. Root 2 square will be 2 over 1 over root 2. So we solve this. The LCM there is 2. 1 will go into 2 ones. 2 times 1 will be 2 minus 2 will go into 2 once times 1 will be 1. All over 1 over root 2. So this will be 1 over 2 divided by 1 over root 2. So what are we having? I have 1 over 2. You can rewrite that as 1 over 2 divided by 1 over root 2, which we can change the problem to become multiplication problem by reciprocating. So we say 1 over 2 times root 2 over 1. 1 times root 2 will be root 2, and 2 times 1 will be 2. Then we can say that 1 minus sine square x over cos x will be equal to root 2 over 2. I hope you get that. So please, the next question, you can pause the video and try to see if you solve. After that, you compare your answers with mine. Say if cos x is equal to 1 over root 2, and that x is greater or equal to 0 degrees but less or equal to 90 degrees, we should evaluate 2 tan x plus root 2 sin x. So how do we do that? Remember, they are all in the first quadrant per the interval given. So from our Pythagoras theory, we're trying to find the other trig identities. So if this is x, remember our mnemonic scheme again. So ka tua. So the cos is given. And remember, cos is adjacent over the hypotenuse. Our adjacent, remember the side which is not against the angle, will be the 1, and the hypotenuse, which is root 2. So we can find the opposite, maybe let's say y. So remember from Pythagoras theory, the hypotenuse, which is root 2 all squared, will be equal to y squared plus 1 squared. So remember, root 2 squared will be 2 equal to y squared, and 1 squared is 1. So we can say y squared is equal to 2 minus 1. Y squared will be equal to 1. Y will be equal to the square root of 1. Remember, plus or minus. And that will be plus or minus 1. Remember, however, that since x is fine in the first quadrant, we will make use of the positive. So y is equal to 1. Or y is equal to 1. Or the opposite is 1. So now we can find tan. Our tan x, remember tan is opposite over adjacent. What's our opposite? 1. What's our adjacent? 1. So that's 1 over 1, which is equal to 1. Then we find sine x. Sine is opposite over hypotenuse. What's our opposite? 1. Our hypotenuse is root 2, so 1 over root 2. Then, since we know sine and tan and sine, we substitute into this expression to find the value. So in evaluating this now, you can say this will be 2. What's our tan x? Tan x is 1 plus root 2 times sine x is 1 over root 2. 2 times 1 will be 2. See, root 2 divide root 2. So we have 1. So 2 plus 1 is 3. And we can say 2 tan x plus root 2 sin x will be equal to 3. And that's if cos x is 1 over root 2. I hope you get that. Okay, so we'll solve our next question again. Please feel free to pause this video and try solving. So given that 4 tan x is equal to 3, where x is greater or equal to 0 but less or equal to 90, or it implies that x is fine in the first quadrant, we should evaluate 1 plus cos x over 2 minus cos x. So how do we do that? So remember, we say 4 tan x is equal to 3. When we divide both sides by 4, the tan will remain low, so we make tan x the subject. So tan x will be 3 out of 4. So since we know tan x, we can find cos x in this instance using the trig identities or using the Pythagoras theory. So from our mnemonic scheme, there's so, ka, and toi. Tan is opposite over adjacent. So our opposite is 3 and our adjacent is 4. Then we can find the hypotenuse. Say, let's say y. And you can say our y squared from Pythagoras theory will be equal to 3 squared plus 4 squared. So y squared, 3 squared is 9, 4 squared is 16. Y squared will be equal to 9 plus 16 will be 25. Y will be equal to the square root of 25. And y will be equal to 1 plus or minus 5. However, since it's found in the first quadrant, we'll just deal with the positive. So we can say y equal to 5. Then we can find our sine, or we can find cos. Since there is no sine in this, there is no need finding it. So we can find cos. So cos x, remember, cos is adjacent over hypotenuse. Our adjacent is 4, the hypotenuse is 5. Then cos s will be equal to 4 out of 5. So since we know cos s, we substitute into this expression to find its value. So in substituting, we have 1 plus our cos s is 4 over 5. So 1 plus 4 over 5 over 2 minus cos s. So 2 minus cos s is 4 over 5. So we simplify the numerator, simplify the denominator. So we can say this is over 1. So we have the LCM to be 5. 5 divided by 1 is 5 times this will be 5 plus 5 divided by 5 will be 1 times 4 will be 4 over the LCM here too is 5. 5 divided by 1 is 5 times 2 will be 10. And 5 divided by 5 is 1 times 4 will be 6. So times 4 will be 4. So minus 4. So 5 plus 4 will be 9 over 5 divided by 10 minus 4 is 6 over 5. And we can change this to multiplication problem by reciprocating. So say 9 over 5 times 5 over 6. 5 will divide 5, so we'll have 9 over 6. So 3 will divide 9 3 times, divide 6 twice. Then we can say 1 plus cos x over 2 minus cos x will be equal to 3 out of 2. So solve our last question on this. But before we do that, please remember to do these 4 things for me. Subscribe to my channel if you are here to like, comment, and share my videos. This will make my channel grow more and I will share more video content with you. So now they say if sine x is equal to half or 1 over 2, where x is greater or equal to 0 but less or equal to 90, we should evaluate sine x cos x over cos x plus tan x. Remember, we don't know cos x, we don't know tan x. So we need to find out using the Pythagoras theories. So this will be our x, our mnemonic scheme, so ka, toi, where sine is opposite over hypotenuse, which is given. So we can say our opposite is 1 and our hypotenuse is 2. Then we can find the adjacent, say y or any variable. So from Pythagoras theory, the hypotenuse square is equal to the square of the sum of the other side. So 1 square plus y square. 2 square is 4. 1 square is 1 plus y square. So our y square will be equal to 4 minus 1. Y square will be equal to 3. So our y will be equal to the square root of 3. Remember, plus or minus. However, since s is found in the first quadrant, we just take the positive. So y will be equal to root 3. So now we can find cos. We know sine, we can find cos. So our cos x will be equal to, remember cos is adjacent over hypotenuse. What's our adjacent? Our adjacent is root 3. And what's our hypotenuse? Is 2. So root 3 over 2. And our tan x will be equal to tan x. So tan is opposite over adjacent. What's our opposite? Is 1. And our adjacent is root 3. So 1 over root 3. So our sin x was given to us to be half. We evaluate cos x, we have root 3 over 2, and tan x we have 1 over root 3. Since all of them is having a whole number which is rational, we need to rationalize the tan. So we rationalize by multiplying both the numerator and the denominator by the rational number, by the irrational number. So 1 times root 3 will be root 3, and root 3 times root 3, that will be root 3 squared. So this will be root 3 squared is 3. So we say tan x is root 3 over 3. Now we can substitute this. So sin x is half times our cos x, which is what? Root 3 over 2. All over, as our cos x, that will be root 3 over 2 plus tan x, which is root 3 over 3. So when we evaluate that, 1 times root 3 will be root 3, then 2 times 2, that will be 4. All over, we'll find the LCM. The LCM of 2 and 3 is 6. 2 will go into 6 3 times. Times 3 will be 3. Times root 3 will be 3 root 3. Plus 3 will go into 6 twice. Times root 3 will be 2 root 3. So when I evaluate this, we'll have root 3 over 4 all over 3 root 3 plus 2 root 3 will be 5 root 3 over 6. We can rewrite this as root 3 over 4 divided by 5 root 3 over 6, which implies that root 3 over 4 times 6 over 5 root 3. So when we simplify this further, see root 3 will divide root 3. Then we'll be left with 1 times 6 over 4 times 5. 1 times 6 is 6. 4 times 5 will be 20. 2 going to 6 3 times, going to 20, 10. And you can say that our sin x, cos x over cos x plus tan x will be equal to 3 over 10. I hope you had the same thing. Please, we'll end it here again. Until we meet again, remember to subscribe to my YouTube channel. My name is Teteji Kepsi Richard.